Okay, looks like it's time to get started. Thank you everyone for joining our live lecture today. My name is Isaac and I'll be the lead instructor for the lecture. And today's topic will be database foundations in NoSQL. So let's first start off by talking about what is a NoSQL database. Okay, and simply put, a NoSQL database is a database that allows the insertion of data without a predefined schema. Okay, and so what that means is in traditional databases, what you would have to do is you would have to define a structure for your data before you put it in your database. But with NoSQL, it simply adapts to the structure of our data as we place it in there. Okay, so the type of NoSQL database we're going to be learning about today is called MongoDB. Okay, and so you'll need to install MongoDB on your local machine. And then we're going to be using a service called MLab to host our data in the cloud instead of our local machine. Okay, so to get started, we simply need to create a new database. Okay, and so I'm just going to select AWS, my cloud provider, and Sandbox for the free plan, and then the region nearest me, and then the database name. So we'll call it our awesome DB. And continue. Okay, verify or order and submit. And it will initialize our database for us. Okay. So from here, we can click our database and let's just discuss the structure of this database. Okay, so first down here we got collections tabs, and collections are basically groups of data within our database. Okay, so you can think of like on your Facebook account, you have user collections, right, of user data, but then you also have like post collections, right? And there's different groups of data and they're separated in collections in our database. And within each collection, we're going to have individual representations of data called documents. And each document is going to have field value pairs. So each field will have a given value represented in JSON format. Okay, this tab is our users tab, and this is how we can authenticate different team members to work with our database. Okay, so normally the account would be like a company, and then you would just designate different database users. So I'll say Isaac is a database user with a password of 123. Create. Okay, so now we can use this user to authenticate and connect to our database. Okay, this next tab is stats, and that's pretty self-explanatory. You know, just lets you know the stats, what's going on. Backups, this is how you can back up your data, you know, in the event that it gets deleted or compromised in some way. And then tools such as exporter, so you can export your data and, you know, do analysis of it through, you know, specific programs like R. Okay, so now we've gone over the basic structure of our database. Let's go ahead and start off by copying this line right here that says connect using the Mongo shell. And the Mongo shell comes as part of the MongoDB installation. So all we need to do is we simply need to say Mongo, and then we need to pass in the string. Okay, so looks like I put Mongo twice at the beginning there, so let me just try this again. Okay, and now I just need to go back and I need to change out the database user to match the one I just created. And same with that database password, has to match as well. Okay, so now I'm connected to my database and I can interact with my database in the cloud. Okay, and so there's 4 common operations that are referenced when dealing with databases, okay, and those are called CRUD, and that stands for create, read, update, and delete. And when you think about it, those are the only 4 operations that ever really take place on the internet anyway, okay, and so let's go ahead and first learn how we can create data by inserting it into our database. So I'm just going to start off by adding a collection, and let's just say we'll have some cars data. Okay, as you can see, we have 0 documents at the moment. So let's go and insert a document by saying db.cars.insert1. Okay, and then I'll make the type of car Tesla. And let's make the year of the car 2018. Okay. So we execute, we can see acknowledge as true, so that was successful. So if we refresh here, we can see that automatically created the document for us, right? It has the type and the year that we assigned it, and then automatically generates this unique ID. And that way we can have multiple cars with, say, the same type of Tesla, and we can still separate them because they'll have a unique ID. Okay, so let's go ahead and add a couple other cars. Let's say db.cars.insert one, and we'll go ahead and insert type of car equals Mercedes. Okay, and year of the car is 2000. Okay, and let's insert one more car. Oops. And let's make this car a type of BMW. And the year we will make 2006. Okay, so if we go back to our database now, we can see that we have all three of those documents. Okay, so as you can see, inserting data really is, not too complicated. You just gotta, specify the database, which in our case, and the collection would be cars, and then the method you want to use, which in our case, we're just inserting one. Okay, so now we know how to insert data and create it. Let's go ahead and move on to how we can read that data from the database. Okay, so let's just start off by reading all cars. Okay, and that we could do this, we could simply say db.cars.find. Then we're just going to leave this parameter field empty here for our filter. Okay, and from here, as you can see, it returns all cars in that given collection. Okay, so now the question comes, well, how can we query cars using specific conditions, right? More fine-grained control. Well, let's go ahead and explore how we can do that. So first, let's explore how we can query car by its equivalence. Okay, so let's say we want to query all cars with a type of Tesla. So how we could do this is we could say db.cars.find, and then we could say type. We could use the equal to operator, and we can make it equal to Tesla. Okay, and as you can see, when we execute that command, it only returns one document, right? And that's the car with the type of Tesla. So this is how we can query cars by their equivalents. Okay, next, let's go ahead and let's see how we can query cars by using comparison operators. Okay, so let's say I want to find all cars that are greater than 2005. So I could do this. I could say db.cars.find. Then I could say year. We could use the greater than operand. And I could say 2005. Okay, close that up. We can see now it only returns two documents, right? And that's these year 2006, 2018, because this other car is less than the year 2005, right? So it does not return that one. So if we wanted to get the opposite, if we wanted to get all cars that were less than 2005, we could simply reverse it. We could say db.cars.find year, and then we'd use the less than operand, and we'd say 2005. Okay, and as you can see now, we only get one car returned. Okay, and that's because it's the only car that is less than 2005. All right, moving right along, let's go ahead and let's explore how we can set up more complex queries if we need to evaluate more than one condition. Okay, so let's say we want to find all cars that are greater than 2005 and less than 2010. So how we could write this in a query is we could say db.cars.find, and then we would pass in the and with an array of our conditions. Okay, so I will say year of the car will be greater than 2005. Okay, and then the year must also be less than 2010. Okay, so when we execute that query, we can see we only get one document returned. And that's the document with the year 2006, because that is greater than 2005 and it's less than 2010. Okay, so next, let's go ahead and let's talk about projections. Okay, so projections are ways that we can query only the data we need from a document instead of the entire document itself. Okay, so let's say we only wanted the type of car and we didn't care about any other data. So how we could do that is we could say db.cars.find, and we'll pass in type. Okay, and then we'll say 1. Okay, and we can see that it got all cars for us, except now it's only returning the type, right, and not the year with that. Okay, and so normally, we're going to want to use this ID, right? But if maybe for some reason we didn't want the ID, we just wanted the type, we could run a similar query. We could say db.cars.find, and then we could say type 1, comma, and then we would do underscore ID 0 for false. Okay, and as you can see, when we execute that, now it's only returning the type to us out of that document. Okay, and this is how we can increase performance. When there's lots of queries being made to your database, it can really bog down performance. So you want to query as little information as possible, and this is what a projection is for. Okay, so moving right along, we've covered how to create, insert data into our database as well as read it. So let's go ahead and let's wrap up how we can update and delete that data as well. Okay, so let's go ahead and let's say we want to update our Tesla from the year 2018, 2019. So how we can do this, we could say db.cars.update. Okay, and then we're going to go ahead and we're going to set up the Bling set operand here once we target the car with the type of Tesla. Okay, so we'll say type Tesla, say Bling set, and then we will set the year to 2019. Okay, looks like I got an unterminated string. Let's try that again. Update 1. Okay. Type equal to Tesla. Then we use our Bling set operand to set the year to 2019. Okay, so as we can see, it acknowledged as successful. So now if we go and we look in our documents, we can see that when we refresh, it goes from 2018 and now it is 2019. So that's how we can update documents using MongoDB. Okay, so now let's go ahead and let's learn how we can remove these documents. Okay, so let's say we just want to remove the car with the type of BMW. So how we could do this, we could say db.cars.remove. Then I'm going to go ahead and I'm going to target the car by its type. Okay, so we'll say remove type equal to BMW. And yeah, let's actually delete one. It's not removed. There we go. Okay. So as you can see, it acknowledges successful. Okay, so I hop back to my browser here in MLab and I refresh. We can see that it deleted the car with a type of BMW. Okay, so now you've seen full CRUD in action. Okay, and if you remember, that's create, read, update, and delete. And really, that's all we're ever going to be doing to our data in our database. So once you get these 4 operations down, it tends to be really smooth sailing from there. Okay, so next, let's go ahead and let's talk about the subject of indexes. Okay, so MongoDB allows us to create indexes, which are just ordered copies of documents in the event that we query specific fields on documents quite often. So if we look in our current setup here in collections, we notice we have an indexes tab, and it's already set up an index for ID. And that's because this field is queried very often. So that's the idea behind an index, is fields that you query very often, just create an ordered copy of that, and then it can be referenced in the index and looked up a lot faster. Okay, so let's go ahead and let's create an index for, let's say, the type of car, right? Let's say that's a field that's queried often. So how we can do this, we would say db.cars.create index. And then from here, we could go ahead and we could pass in type of 1 for true. Okay, and as you can see, it acknowledged as successful. We come back to MLab and refresh. We can see that we have an index for type and an index for ID. So now every time I search for type, it's going to be faster and more performing because I have an ordered copy of that. Alrighty, so next, let's go ahead and let's talk about one-to-many relationships. Okay, so a one-to-many relationship, it really is explained within its title, right? It's when you got one piece of data related to many. Okay, and so if you think about the internet, there's actually a ton of one-to-many relationships going on. So let's just take a quick example of one at Yelp.com. Okay, so Yelp has a single category that's related to, many places, right? So let's go ahead and let's just look up restaurants near this place. Okay, and so now we got an idea of how one category is related to many places. Let's go ahead and create a similar operation in our own setup here to where we are simply taking categories and places and referencing them with a one-to-many relationship. So to get started, let's go ahead and let's go to MLab and let's set up our collections for categories and places. So we'll add a collection for places, and we'll add a collection for categories. Okay, so now we can populate these with documents. Let's go ahead and let's set up a couple different places. Okay, so I'm going to go ahead and I'm going to say dp.places.insert1. Okay, and let's just start with the name of the place, which will be Disneyland, and the category of the place is going to be entertainment. Okay, that was created, no worries. Let's create one more place for this category, just so we have a couple to work with. Okay, and let's go ahead and say the name of this one is Universal Studios. And the category will be equal to entertainment as well. Oops, looks like I never ended that one correctly with the correct syntax. Let me try again. db.places insert one, and then the name of the place we will say is Universal Studios, and the category is equal to entertainment as well. Okay, so we'll go ahead and close up these brackets. Okay, now let's make one last place. And let's call this place a food place. Okay, so the name will be In-N-Out Burger. Okay, and the category will be equal to food. Okay, so now if we head back, we can see that, oops, looks like it logged us out. I'll go ahead and log back in. We can see that we have these three different places, and each of these has a category attached to it. Okay, so now we have multiple documents related to single places. So if we wanted to run a query similar to Yelp and we want to find all the entertainment places near us, we would say db.places.find, and then we would find all the places with the category of entertainment. Okay, so I would just say category is equal to entertainment. Okay. So as we can see, now it pulls up two places, right? Disneyland and Universal Studios, because both of those were equal to an entertainment as the category. So in that same approach, we could search for the food. So we say db.places.find. The category would be equal to food. Okay, so as you can see, it only returns one document now, right? And that's because the category was equal to food. Okay, so now we've just created our own one-to-many relationship. And during our server-side operations, we can easily add more categories and populate them with places and their nested array values. Okay, so let's go and open the floor, and let's see if anyone has any questions before we wrap up today. Okay, so the floor is open. Feel free to ask away. Okay, doesn't appear to be any questions today. Thanks everyone for stopping by. Have a great rest of your day, and happy coding out.